Good morning. Today we're going to do the Chapter 5 review. Just take a quick look at a couple things before we get started here. First of all, when we estimate fractions, we're estimating to the closest 0, the half, or the whole. So this is a bad 8 here, but 1/8, we would round that to 0. If it was 4/8, 3/8, or 5/8, we would probably round that to a half. If we had 7/8, we would probably round that to a whole. So the point of estimating is to be able to do an answer in our head, to get a sum or a difference. So take a look at this problem. We have 6/7. Is that closer to 0, 7s, a half, which would be 3.5 sevenths, or a whole? Well, 6/7, it's almost a whole, so we're going to call that 1. Now we have 3/8. Well, like I said before, 3/8 is pretty close to a half, so we're going to call that a half. So our sum for this problem is 1 and 1/2. This next problem, we have 3 2/5 minus 2 5/7. With mixed numbers, we just round to the nearest whole. Round to nearest whole. Starting to sound like Silicon just a little bit. And so we look at this, it is 3 2/5. That is, well, it's less than a half, so we're going to call that 3. And we have 2 5/7. That's more than a half, so we're going to call that 3. So you have 3 minus 3, which equals 0. Okay, so the rule for fractions. Round it to the closest 0, the closest half, or the closest whole. Mixed numbers. Round them to the nearest whole. All right, we're going to use those same things to generate a reasonable product or a quotient. In other words, we've got multiplication and division problems we're going to do. Now we have 1 6/7. We have 1 whole and 6 parts out of 7. So that's nearly 2. So we're going to call that 2 times 1 1/8. Well, that's just a little bit more than 1. We're just going to call it 1. If you think of 1/8 of a pizza, that's not much. 2 times 1 is 2. Here we have 40 divided by 3/4. Well, we've already got this one rounded for us, 40. And 3 3/4, that's almost 4. So we're going to call this 40 divided by 4, which is 10. One other problem I'm going to put down here, 30 1/2 divided by 3 3/4. Well, this one here we would probably round to 31 divided by, again, 4. But 31 divided by 4, that's not something I can do quickly in my head. Remember that you can also use nearby compatible numbers. Like I'm just going to round that to 32 divided by 4 because I know that that's 8. So sometimes you have to tweak the numbers of the estimate a little bit so you can do it in your head. But these are just guidelines. All right, these guidelines will be followed on the test though. All right, 5.2c. If you can't do this target, you're going to struggle on the test. So it's probably the most important target on the test. You have to be able to take a mixed number like 4 2/3 and make it into an improper fraction. An improper fraction is something like 9/8. It's too big on top. Mrs. Wooten calls it an ice cream cone. It's got the big scoop of ice cream and then the little cone. It's improper. This one here is a mixed number. I'm going to rewrite this as 4 2/3 so I can show you how to do this one more time. You multiply the wholes times the denominator and then you add in the top. I always put these marks like this to help me remember. Sometimes I put a plus and a multiplication sign there. 4 times 3 is 12, plus 2 is 14, and you keep the denominator. That one is 14/3. Okay, let's take a look at 42 and 42 35ths. We can do this a couple of ways. You can take 42 35ths, and the first way you can think about it is you could just think, well, this one's larger, so there's at least one whole in there. So there's 35 35ths in a whole. So if you subtract that out, you're going to have, that would be the one whole, and 42 minus 35 would give you 7 35ths left. Now, 1 7 35ths isn't the simplest form, so if you divide the top and the bottom there by 7, 7 divided by 7 is 1, 35 divided by 7 is 5. You have 1/5, so it's 1 1/5. That's one way of doing it. Another way to do it is to, just think of old-fashioned division. 42 divided by 35, that's what this means. 42 divided by 35. It's going to go in there one time, and you're going to have 7 left over. And here it is again. Here's your 1 whole and 7/35, which again you can reduce down to 1 1/5. Calculator on, so I'm going to slide mine in here and get ready to read this problem. The Crothers split a pie. Mom ate 15%, Declan ate 20%, Dad ate 40%. How much of the pie was left over? Well, this is pretty simple when you really think about it. We have 100% in a whole pie, so we have 100%, and I'm just going to subtract out what Mrs. Crothers ate. I'm going to subtract out what Declan ate, the 20%, and I'm going to subtract out what her husband ate. And we can do this on the calculator. 100, take away 15. Oh, 100 minus 15 minus 20 minus 40. I got 25% left. And then just to be certain, I would double check that and subtract that one more time. But I can also add it back up. This would be 60%. This would be 70% and 75%. So the opposite would be they ate 75%. There's 25% left of the pie left. Okay? All right, still got that calculator going here because I've got this problem about Mr. Zenz here. Mr. Zenz drove 650 miles on a 7-day trip. He rented a car. He paid $20 per day plus 15 cents per mile. That 0.15 is, another way to write that would be $0.15 or 15 cents. Either way. After he got paid 15 cents per mile after 500 free miles. How much did the rental car cost for the trip? All right. Well, he had 7 days, and he paid how much a day? $20 per day. So $7 times 20 is $140. He paid $140 for the car. This is the car. He also paid miles. Now he got 500 free, so the first thing I'm going to do is I'm going to take the 650 miles and I'm going to subtract the 500 that he drove that are free. He has 150 miles he has to pay for. So I'm going to take 150 miles times 0.15. That's what he has to pay per mile. That's going to be another total. So let me get my calculator for that. 150 times 0.15 equals $22, 22.5. Well, that would be 22.50. So I can just take and add that plus the 140 that he had to pay for the rental car, and I got a total of $162.50. So those problems you will be able to use your calculator on. There's going to be some two-step problems. This was actually a one-step, two-step, three-step problem. We had to subtract 3 different things. This one here, find the total for the days, find the total for the miles, and then add them together. You can think about that as a 2 or a 3-step problem. All right, I can multiply fractions without a calculator. I can get rid of that calculator now. We have 1/2, and we're taking it times 3/8. Do you want to pass this test? Rewrite the problems every time. Rewrite them neatly so you don't have those goofy fraction slash bars. When you multiply fractions, you just multiply straight across. 1 times 3 is 3. 2 times 8 is 16. 3/16 is your total. 5/8. I'm going to rewrite this guy. 5/8 times 4. Remember that asterisk means multiplication. So does a dot. All right. Yikes. What do? I only have one fraction. Oh, wait. I can put the 4 over 1 and make it a fraction. And then I can just multiply straight across. Or I can cross reduce. I'm going to cross reduce. 4 divided by 4 is 1. 8 divided by 4 is 2. I can't do anything here, but watch how simple this is. 5 times 1 is 5. 2 times 1 is 2. I've got a total here of 5 halves. So what I have to do then is I have to divide that out. There's my ice cream cone. 5 divided by 2. Well, it goes in there 2 times. 2 times 2 would be 4. and I've got 1 left over. So here's my answer. 2 and 1 part out of 2. 2 and 1/2. Look good? All right. I'm going to do this problem one other way. When we have 5 halves, let's say we want to subtract out a whole. Well, that would be 2 halves. So there was 1 whole. 5 minus 2 is 3. I can do that again. Take out another whole. So I've taken out 2 wholes. Now I have 5 minus 2 minus 2. So I've got 1 left over. And there's your answer by using subtraction. 1, 2 and a half. 2 and 1/2. All right? Told you I'd get back to that. All right, I can multiply mixed numbers without a calculator. Same thing. Rewrite those numbers so you can see them. 1 and 1/3 times 4 and 2/3. Well, the first thing you got to do is convert these babies to improper fractions. 1 times 3 is 3 plus 1, 4/3. 4 times 3 is 12 plus 2 is 14/3. Okay, now we can try to cross reduce. 14 and 3, I can't do anything there. 4 and 3, I can't do anything there. I guess I just have to multiply. 4 times 14, well, 4 tens is 40, and 4 fours is 16. So 4 times 14 will be 56. 3 times 3 is 9. Now I've got that snow cone thing there. Well, let's go ahead and divide this out. 56 divided by 9. Well, it doesn't go into 5. It does go into 56. It goes in there 6 times. 6 times 9 is 54. I've got 2 left over. So my answer to this problem, I'm going to squeeze it in right here, is 6 wholes. And I have 2 parts out of 9 remaining. Okay? This next one here, I'm going to just take and move this guy right down into this corner down here. We have 1 3/5, 1 3/5, and we are going to multiply that times 1 1/2. Well, we need to make these into improper fractions. 1 times 5 is 5 plus 3 is 8/5. We're taking that times 1 times 2 is 2 plus 1 is 3/2. All right, so I've got to take and see if I can cross reduce. I can't cross reduce the 5 and 3, but I can divide this by 2 and I get 4. I can divide this by 2 and I get 1. Now I can just multiply straight across. 4 times 3 equals 12. 5 times 1 equals 5. I have 12/5 is my answer. So let's take and divide that out. I got my ice cream cone thing again. So let's take 12 and we'll divide it by 5. 5 doesn't go into 1, but 5 goes into 12 2 times. 5 times 2 is 10. I subtracted out. I got 2 left over. So my answer is 2 wholes. Slide that up for you. 2 wholes. That's the answer to the problem up top. Your remainder becomes your numerator, and 2. And your divisor becomes your denominator. So 2 and 2/5. So again, your remainder becomes the numerator, divisor, denominator. All right, 5.5c, you're going to have some problems where you have to solve some mixed number problems. These will probably be multiplication, maybe some division, more than likely multiplication. So Miss Goldman runs 1 2/5 miles in 10 minutes. How far can she go in a half an hour? Well, we got minutes and hours here. So first of all, I'm just going to say a half an hour here is 30 minutes. That makes life much simpler, doesn't it? So if she can run this far in 10 minutes, how far can she run in 30 minutes? Well, I could take this times 3, or I could just take 1 2/5 plus 1 2/5 plus 1 2/5, because this is what she can do in 10 minutes. So I'm going to multiply these out. 1 times 5 is 5 plus 2. So I got 7/5 here. And I'm going to multiply that times 3, or times 3 over 1. I can't do any cross reducing there. Nothing works. So I just got to go straight across. 7 times 3 is 21. 5 times 1 is 5. 21/5. Well, 21 divided by 5. It goes in there 4 times. 4 times 5 is 20. There's one remainder. So she can run 4 and 1/5. 4. Remainder is the numerator. Divisor is the denominator. 4 and 1/5 miles in 30 minutes, or in a half an hour. And that makes sense. If she can run about 1.5 miles in 10, she could run about 4.5 miles in 30, or 3 times that amount. Okay, let's see if I have another 5.5c. Nope, 5.6a. Let me slide this down so you can see it. The old multiplicative inverse. There's going to be 4 of them on there. You can't miss these, but some of them are kind of tricky. Remember, the multiplicative inverse is a vehicle to get to 1. So if you have 1/8 and you multiply that by 8 over 1, you get 8/8, which is equal to 1. If you have the number 6 and you want to get to the number 1, you can multiply it. That's really 6 over 1. You can multiply it by the reciprocal, or the multiplicative inverse. Sorry about that. Which is 1/6. 6 times 1 is 6. 1 times 6 is 6. 6 divided by 6 is 1. I don't want you to miss any of these problems here. So here's one right here. You want the reciprocal of 5? Well, here's 5. 5 is a fraction, could be 5 over 1. So the reciprocal would be 1/5. You multiply by those, you're going to get 1, because you have the same product, 1 times 5 and 5 times 1, on top and bottom. Find the reciprocal of 1/3. This one's a slam dunk. Nobody's going to miss with this one. That would be 3 over 1, or just plain 3. Okay, because again, if you multiply these guys together, you would get 1. All right, I can solve equations using the multiplicative inverse. Well, here's where you have to use some of these. So I'm going to take and rewrite this equation. It's x 12 equals 5. Now keep in mind, that's not just one, that's not 2 or 3 x's. This is just a single x. So if I put a 1 in front of it, I can help see my fraction that is 1/12. Well, to get rid of 1/12 x, we need to get to a whole x. We need to get to 1. We can't figure out what x is until we know what a whole x is worth. So we have 1/12 here. I'm going to multiply it by 12 over 1. Notice how the 12s and the 1s cross off, leaving me just a full x. But I have to multiply that on the opposite side too. So I'm going to call that 12 over 1. Now I've got 5 times 12, which is 60. 1 times 1, which is 1. 60 over 1 is just 60. So x is equal to 60. And let's see if it makes sense. 60 divided by 12 is 5? Yes. On the test, you absolutely need to show the crossouts. Otherwise, it won't count. Here's another tricky one. 3 equals k over 16. Now, I wrote it backwards, but it's the same thing. It's 1k. So I'm going to make that look more like a 1. 1/16 k. Well, the opposite of 1/16 is 16 over 1. The 16s cross off, the 1s cross off. You're left with just plain old k here. But you multiply it by 16 over 1 on this side, you got to do the same on the opposite side of the equation. Because whatever you do over here on this side of the equals, you have to do on the other side of the equals. So you've got 3 times 16, which is 48. You could do 48 over 1, but ultimately your answer there is 48. Let me see if I can do another one here. That's actually the easiest, I think, is when you have 2/3 m equals 6. In other words, 2/3 of something equals 6. Well, 2/3 is my fraction, so I want to get it to 1, so I'm going to multiply by the opposite, which is 3 over 2. These cross off, just leaving m. Got to do the same on the other side. Well, 3 times 2 here, or 6 times 3 here is going to give me 18. 1 times 2 is 2, so I have 18 over 2, or 18 divided by 2. 18 divided by 2 is 9, so m is just equal to 9 in that situation. Okay, 4 problems left. We've got to divide fractions efficiently without a calculator. Well, the key here is keep, change, and flip. All right, flip it good. So again, I'm going to rewrite these problems. I hope you will too. 4/5 divided by 1/2. All right, I'm supposed to keep the first one, 4/5. I'm supposed to change the sign to multiplication, and I flip the second one. So instead of 1/2, I flip to the reciprocal, just like we were doing up here. Multiply across, because I don't see any cross reductions. 4 times 2 is 8. 5 times 1 is 5. I have 8/5, which if I take 8 and divide it by 5, it's going to go in there 1 time. We got 5. I've got 3 left over, so my answer is 1 and 3 parts out of 5. 1 and 3/5 is my answer there. All right, let's take a look at this guy here. We have 1/2 divided by 1/8. Okay, well, I'm going to keep it. I'm going to change it. I'm going to flip it. Oh, look, I can divide on this one. I'm going to divide by 2 is 1. I'm going to divide by 2, it's 4. 1 times 4 is 4. 1 times 1 is 1. I've got 4 over 1. 4 divided by 1 equals 4. And we're down to 2 problems left. 5 and 2/5 divided by 1 and 1/2. So I have to write these down nice and neat. 5 and 2/5 divided by 1 and 1/2. All right, first of all, these, because they're mixed numbers, are going to take 2 different steps. So I'm going to put 2 arrows down so I don't forget to do the second step. First of all, I got to change them into improper fractions. 5 times 5 is 25 plus 2 is 27/5. I'm going to divide that by 1 times 2 is 2 plus 1 is 3/2. Now here's where kids make mistakes. They start multiplying, but this is still a division problem. Now we have to do the keep, the change, the flip. So I'm going to keep that first one, 27/5. I'm going to change the sign to multiplication. I'm going to flip this guy, 2/3. I can't do anything with the 5 and 2, but I can divide by 3 here. There's 1 3 in that. There's 9 3s in that. Now I can multiply. 9 times 2 is 18. 5 times 1 is 5. I got 18/5. There's that upside down ice cream cone. 18. I'm going to divide it by 5. 5 does not go into 1. 5 goes into 18. It goes into 3 times. 5 times 3 is 15. If I subtract out, I've got a remainder of 3. So it goes in there 3 whole times, and there are 3 parts remaining out of 5. 3 and 3/5. All right, this one here, 3 and 3/8 divided by 2 and 1/4. My question is, are you willing to write the problem 3 times? Just copied it, change them to improper fractions, and then do the keep, change, flip. If you are, you're probably going to get it right. But a lot of you are just trying to multiply and do stuff in your head. It ain't going to work. I can't do it. I'm not that smart. I know you're smarter than me, but you can't do it either. Trust me. All right, let's get this into improper fractions. I'm going to put my 2 arrows here so I remember. 3 times 8 is 24, plus 3 is 27/8. We're going to divide that by 2 times 4 is 8, plus 1 is 9/4. All right, step 2, keep it, change it, flip it. Flip it good. Lots of stuff here. We can divide by 4. Here there's 1 4, and here there's 2 4s. We can divide by 9. There's 1 9 here, and there's 3 9s there. So when I multiply this across, I got 3 times 1, which is 3. I got 2 times 1, which is 2. I've got 3/2, which is really the same as 1 and 1/2. All right. Slide that over so you can see it. If you want more of a review, you can check out the mid-chapter review. That's also on YouTube. And you can also take a look at the Chapter 5 review reteaching, or the Chapter 5 reteaching. It's me and some slides, and that's excellent review as well. So that's just a bonus review this time. Thank you so much. If you want another copy of this, download it from Moodle. Go to Worksheets, Chapter Reviews, and pick Chapter 5. Have a great night. Bye.